Newton's laws of motion. Forces change the motion of objects in specific ways. A scientist named Sir Isaac Newton was able to state rules or natural laws that describe the effects of forces on the motion of objects. These rules are known as Newton's laws of motion, and they apply to the motion of all objects. Newton's first law of motion states that an object in motion stays in motion, or an object at rest stays at rest until a force acts on it. For example, if you were to kick a ball across a grassy field, then either the ball would eventually hit an object and come to a stop, or it would roll to a stop due to the friction of the grass and the ground. One of the best examples of Newton's first law of motion is thinking about riding in a car without a seatbelt. If the car were to happen to run into another car, the car would come to a stop, but the passenger would keep moving until a force acted upon it. Knowing this, car makers came up with a seatbelt to protect the passenger. The passenger without the seatbelt is demonstrating the property of inertia. Inertia is the tendency of an object to resist any change in motion. If an object is moving, it will have uniform motion and will keep moving at the same speed and in the same direction unless an unbalanced force acts on it. This is why Newton's first law of motion is sometimes referred to as the law of inertia. Another example of the law of inertia, or Newton's laws, would be if you were pulling a wagon up a hill. It takes a lot of force to pull that wagon up the hill, but once you go up over the hill and start heading down, you will notice it actually takes effort for you to stop it or slow it down because it wants to keep moving in the same direction at the same speed. Newton's second law of motion states that the acceleration of an object is in the same direction as the net force on the object. As you can see in the picture, when the soccer player kicks the ball will move in the direction of the force. Depending on the size of the force the player kicked the ball and the mass of the soccer ball will also determine its acceleration. So let's just say if the same player were to kick a bowling ball with the same force, well, one, that would hurt a lot, and two, there would be much less acceleration due to the larger mass of the bowling ball. Newton's second law of motion can be calculated as force equals mass times acceleration. This formula can also be turned around, and you could also calculate acceleration by dividing force by mass. Newton's third law of motion. This law of motion states that for every action or force, there is an equal and opposite reaction or force. When you jump on a trampoline, for example, you exert a downward force on the trampoline. Simultaneously, the trampoline exerts an equal force upward, sending you high into the air. NASA and SpaceX use Newton's third law of motion to launch its rockets. The force of the jet fuel igniting out the back of the rocket exerts a force on the rocket, launching it up into the air. When an object is moving, it has a property called momentum, and momentum of an object is the product of both its mass and velocity. The momentum of an object doesn't change unless its mass, velocity, or both change. Momentum, however, can be transferred from one object to another. Consider the game of hockey or softball. When a swinger swings the hockey stick or the bat and makes contact with the puck or the ball, the momentum of the bat is transferred into the puck or the ball and sends them moving in the direction of the force. Momentum can be calculated as mass times velocity. Okay, it's time to show what you know.